Hi, it's your guy Olumide, and today we are gonna be solving another one of the most commonly asked tech interview question. So in top tech companies including Google and Amazon, Netflix, Meta, Microsoft, Apple, and other top tech companies, the interview question is Verify Sudoku Board. Now, the problem statement says, given a partially completed 9x9 Sudoku board, we are asked to determine whether the current state of the board is valid, given these rules here. And the rule states that, the rule of the game states that each row and column must contain unique numbers between 1 and 9 or be empty. So, and the second rule is that each of the 9 3x3 subgrids that comprise the grid must contain unique number between 1 and 9 or be empty. To understand the problem statement, let's consider this example. What the problem statement is trying to say is that the rules of the Sudoku game state that for each row we are given a 9x9 matrix or board. So, and for each row it needs to contain unique number or unique elements. So they have to contain unique elements and numbers. Like now we have 3 here, 6 here, 5 here, 8, 4. So we must not have duplicate number or 3 repeating itself twice, and then it has to be so for each and every row in the board, meaning that each and every row from the first row to the last row need to contain unique set of numbers per row. So, and the same thing apply to column. Each and every column have to contain unique. This column 1 now, every number in the column 1 should be unique, and then every number in the column 2 up to the last column. And the second rule also talk about the subgrids, 9 subgrid. So in this Sudoku game we have 9 subgrid. This is first one, and this is another subgrid here, and this is another subgrid here. So we have a total of 9 subgrids. This is another one. So if you see 1 2 3 4 5 6 7 8 9, so a subgrid contain a set of cells. So, and we have 9 subgrid in total. One important thing to note is that the question asks us to determine whether the current state of the board is valid. So, meaning that they just want to know if each of the row contain unique numbers, if each of the column contain unique numbers, and each of the subgrid contain unique numbers. So that's simply what the question is asking us to find. Now our primary objective is to check every row, column, and each of the 9 subgrid for any duplicate numbers. So to check them, if a duplicate number is found along the rows, along the columns, or in each of the subgrid, definitely we are returning false. So just like in this example given, look at this particular row that we have here. Look at this row, we see that 2 occur twice in the row. This is the first 2 and this is the second 2. So therefore we are returning false. And even 8 occur twice again here in the column. 8 occur here, 8 occur here. So we are returning false because it does not adhere to the rule of the game. If upon checking through each cell and each row, column, and subgrid we cannot find any duplicates number, then definitely it adheres to the rule and true will be returned. Let's start by figuring out how to check for duplicates in a single row and a single column and a single subgrid. To find for duplicates in this single row, we are going to use a hash set to keep track of the previously visited numbers as we iterate through the row. So we iterate through the row and we use the hash map to keep track of the previously visited numbers. Whenever we encounter a new number, we can check if it is already in the hash set in O1 time, because hash set actually uses O1 to check for an element in the set. So if the number has been presently found in the set or previously added to the set, definitely there's a duplicate in the row, just like in this case. Now let's go through this particular single case. Now we are at the first element of the row, and initially our hash set is empty. So we try to check if 1, which is the number at this particular position, if 1 is in hash set, we try to check in O1 time, and because it is not in hash set, we are going to add it there. Then we move to the next index, and the next element is actually an empty cell. So, and because it is an empty cell, we will just continue to move to the next one. We are going to ignore every empty cell because we are treating it like 0. Then we move to the next index here, index 2, and the element or the number there is 2. We try to check if 2 is in the hash set. No, the 2 is not there. We only have 1 in the hash set, so we add 2 to the hash set. Again, we proceed to the next index, and the element and the number there now is 5. 5, we try to check if it's in the hash set. Don't forget, all of this thing takes O1 time, so which is very efficient. So because we are dealing with hash set now, and hash set is going to check in O1 time. So 5 is not in the hash set. So far we've not found a duplicate. We keep on adding, we add 5 to the hash set and keep on moving our index. We moved our index past the empty cell. We continue up to we get to 3, and when we get to 3, we try to check if 3 is in the hash set. So it is not, we had it there, and then we move again to 2. But now 2 is already existing in the hash set, so because it is existing there, duplicates definitely exist in this particular row, and therefore the Sudoku board is not valid, and we are gonna return false. You understand? But in a situation whereby probably this is not 2, this is maybe 7 or some other number, it will just proceed to the next row. So this is how we are going to be checking each row to check if it has a duplicate. The same thing applies to column now. So we just go after each column. So going after each column, we try to add them into a hash set, and whenever we come across anyone that has duplicate, we return false. But the challenge here is that if each row should have a hash set where we are going to use to track any duplicate number, and the first row have, second row we have 2 for the second row, third row we have 4th and 5th, and each column also have a tone. So how are we going to be able to identify which particular hash set out of the 9 hash set rows belong to a particular cell? You understand? Each row is gonna have their own hash set to keep track of that particular row, and each column is also going to have, and each subgrid is also going to have. But now, taking a particular cell, how are we going to identify which out of all these assets belong to it? So how are you going to do that? Well, identifying rows and columns are quite straightforward, because each cell have a corresponding row and column. Look at this first cell, for instance. Now it has a row of 0, row index of 0, and a column index of 0. So, and if we can create a list of 9 hash sets, so we can easily index the first hash set by the index. So the row index of the cell is what we are going to use to get the corresponding and reference the corresponding hash sets. So we will reference it by the row index and by the column index. So we see that is quite straightforward, but subgrid pose an interesting challenge because we can't immediately identify which subgrid a cell belongs to, unlike the straightforward index-based representation and identification of for rows and columns. So rows and column are index based. Fine, this particular index, this particular element 3 here is in row 0, 1, 2, and immediately we will go and get the row from the row sets from this array. So, and is in column, is this column probably 6, so column 6, and we get the column, we will index it from the column set. But you know, we can't do that for the subgrids. By carefully observing the left board and the right board, we will notice that each subgrid is it contains a collection of cells. Each subgrid contains a collection of cells, and we will notice that every cell with a row index of 0, 1, or 2 and column index of 0, 1, or 2 belongs to the first subgrid, and every cell with a row index of 0, 1, 2 and column index of 3, 4, 5 belong to the second subgrid. And similarly, every cell with row index of 0, 1, 2 and column index of column index here of 6, 7, 8 will belong to the third index, belong to the third subgrid. Now the question we should ask ourselves now is that how can we categorize the cells such that whenever the cell have a row index of 0, 1, 2 and column index of 0, 1, 2 is gonna, you know, is going to come and check this particular subgrid. So the subgrid hash set is what is going to come and check. So that's what we actually want to do, in such a way that every cell with row index of 0, 1, 2, column index of 0, 1, 2 will come and check the hash set here to look for duplicate, and every cell with row index of 0, 1, 2 and column index of probably 3, 4, 5 will come and look at this second subgrid. So how do we do that is what we are going to work on now. We can do this and achieve this by finding the corresponding row and column index of each cell. Let's take for instance now, okay, we want to find the particular subgrid that this particular cell is here. So first of all, we know that the row index of the cell is 0 right from here, and the column index is 6. So by finding the quotient of this 0 and 6, finding quotient of 0, quotient 2, we give quotient 3 will give us 0. So quotient actually means when you divide it by the other number, what is it going to give you? What's the quotient? So why C, you know, C divided by 3 will give us a quotient of 2. You understand? So, and when we look at it in this particular diagram, you see that 0 to 2 means 0, 1, 2. It means that this first grid 0, this second grid 1, and this third grid. So because this grid on its own is a 3 by 3 board on its own, look, is a 3 by 3, 0, 1, 2, just like we have here, 0, 1, 2 and 0, 1, 2. So when we have 0, 2, it means this particular one here. So that's exactly how we can find any cell. Whenever you have the row and the column, just find the floor division by 3 by 3 for the row index and the column index, and it will give you. So this way now we can find the subgrid, the subgrid hash sets. So we can identify which particular subgrid a particular cell is just by looking into its row and column index and finding the floor of them. Now that we know how to look for a particular cells, row sets, column sets, and subgrid sets, which I hope you understand. So you know, for this particular cell now, this is the subgrid set. You understand? And we have talked about the row and the column set as well. So let's now summarize the whole logic. So first of all, we initialize the hash sets. So 9 hash sets for the rows. Don't forget that each of the row we have their own hash set, so that we can try to look for duplicate across row. And because we have 9 rows, we are going to be having 9 hash sets. And similarly now, column 2, we are going to be checking for duplicate across columns. So we are going to be having 9 columns now. And because we have 9 subgrid sets, this subgrid is 9, and we have to check for duplicate across subgrid. So we are going to be having 9 subgrid set that is in this 3x3 format, because of, you see, 0 1 2 0 1 2, so it's a 3x3 format. And what we do again after initializing is that we iterate through each cell one by one. We are gonna iterate first. We are gonna iterate through this one and try to check the row set. This row set that it is, we will check if it has duplicate. We are going to check its column set also if it has duplicate, and we are going to check this particular subgrid set. So that 3 places are what we are going to check if these 3 appear more than once. So if we do, we are gonna return false, just like we specified there. But if it does not, we are going to add it to the appropriate row set, column and subgrid set, so that in case you will see it another time, or you understand, in another situation, we are going to know that, oh, we have it already and that one is a duplicate. Alright, let's go into the code implementation of the logic that we just discussed. So we are going to define our function as Verify Sudoku Board, and so let's call it board. The arguments we are taking in, which is our board now. So we are going to pass in a list of string. So and the output will be a Boolean output. So first of all, let's put in what we are dealing with, so which is the board now. So why I put in list of string is because board itself is a list, but inside of it contain list of strings. That's I say list of strings. And why I put in the Boolean here is because we are returning whether it is a valid Sudoku or not. So it's a Boolean return that we are returning. So right now, let's move on. So like we said, we're gonna be defining our row sets, and our column sets. Our row sets will be this. Don't forget that each of the 9 rows we have its own row sets, and similarly each of the 9 columns we have their own column set. And that's what we are doing here. We are creating column set for each of them. And okay, we are gonna be creating sets also for the subgrid sets. So to be sets, well, this will be a 3x3. You know, we are creating 9, but that 9 won't be in linear line 9, unlike the column set and the row set. It's gonna be a 3x3. So if you could remember the logic we discussed the other time of how we can identify the column, the subgrid set from a particular cell, you know, we need R and C, and we index it like a matrix. So that's why we are going to be using a 3x3. So for I in range of 3, and for underscore in range of 3. So this is a 3x3 array, and now we want to iterate through our board. So, and this is how we can iterate through the board. So by iterating through the rows and then the column, so simultaneously. So you understand? So this way now, for the first row, we are going to traverse the whole column. Then we go into the second row, traverse the whole column. So, and that's what we want to do. And what we want to do is I want to check if board of, that is the particular elements at that particular position, row and column, if is equals to a dot, we want to continue. So while we use dots, actually we are using dot to represent empty space, and whenever we come across an empty space, we just want to continue, because we are not interested in it being unique. We are only interested in this string number string, we are interested in them being unique, so we just continue whenever we come across an empty or a dot. So but if it is not a dot, okay, you need to now check that it does not contain duplicate. So if it exists in row sets of R, which corresponds to the R set for that particular row, so, or if it exists, I mean the element at this position R and C, as we are transversing one by one throughout the board, if it exists in column sets of C, that is column corresponding to that particular position, so, or even if it exists in, even if board of board of R of C exists in subgrid set of R. So don't forget, if you could remember why we are using this quotient stuff, is because is a way of grouping it, because each subgrid consists of a set of columns or a set of cells. So using this quotient is a way of grouping them, you understand? So now if it exists, we are going to be returning false. So why? Because it has defined the rule. The rule says that there must not be any duplicate across the row, column and subgrid. So but in a situation whereby there's a duplicate, we are going to return false. So where if there's no duplicate, we want to add this particular we are going to be adding this particular element, board of RC, in case where we are adding it is so that in case if it occurs some other time, we know that it has existed already in the set and is a duplicate. So same thing, we are going to add it to the column set corresponding to this column. We are going to be adding it to the subgrid sets as well. So don't forget, you can return back to the logic that we discussed if you don't get why we are using this quotient or this floor division to get it. So and this way we'll be adding the same board of R of C, and after doing that we are gonna be returning true. So why we are doing this is because in a situation whereby we loop through the whole cells in the board without returning false, definitely it is valid and we have to return true. But in a situation whereby there's a duplicate, it will always return false before it's finished looping out of the board. So, and that's just what we're doing. And now we can call the function. Right now we can call the function print verify Sudoku board of board. So, and when we run it now, yeah, we have true printed here. So we have the true printed and it works very well. So this well, you might be thinking that the input is the example inputs printed false. This is another test case. This is another another set of board different from the one that was initially given to us. But of course, if we should put input to the one that was given to us, it's still gonna give us the correct answer, which is false. But for this one, there's no duplicate, so it returns true. So let's look into the JavaScript code implementation now. So here we have the JavaScript code implementation. So like I used to say, it's very similar. The difference is just the syntax and probably the speed. So, and what we are doing here also is that we are creating the row set, the column set and the subgrid set. And you know how we create the row sets is that we use an array.from. So And what it does is that it first of all create a demo or dummy array of length 9, and it's gonna create the sets for each of these dummy items of the array of length 9. So same thing is going to apply for the column set. Now it's going to create a dummy array of length 9, and it's going to create a set object for it, and same thing apply to this, just that it's going to create a 3 by 3 array for it. So what we do is just similar to what we did then, is to iterate through the rows up to index 8, index 8. That's why we have less than 9. So because once it become index 9, it will be out of index. So now we did the same for the column 2, since both of them are 9 by 9. So what we do is that for each of the cell in the board, we try to collect the value of that cell. We collect it as VL. And what we do is that if the value is a dot, we continue, because it signifies an empty board. So but if it is not a dot, then we try to check if it is not existing in the row set or column set or subgrid set, and if it do exist in any of the three, we return false. So otherwise we add the value to the row set, add the value to the column set, add the value to the subgrid set, their corresponding row set, column set, and subgrid set. And if we could successfully loop out of the row, out of the for loop without returning false, then we will happily return true. So, and when we run it, it gives us that exact response. So thank you so much for watching, and take care.